Hello everyone, and welcome to the channel Chemistry Without Cramming, a bowl of chemistry knowledge. If you are on this channel for the first time, my name is Agnes, and I'm here to convince you that chemistry does not have to be difficult. Today, I would like to present another way of expressing concentration that we use in chemical calculations. The topic of this video is molar concentration of the solution. First of all, note not molar because it was already mentioned in the previous video, but molar concentration. In today's lesson, you will hear what molar concentration is and how to calculate it. If you like this lesson, please leave a thumbs up, and if you want to follow further topics, subscribe to this channel. Okay, let's start. Molar concentration, molality, is defined as the number of moles of the solute per kilogram of the solvent. In the previous video, we talked about what a mole is and how to calculate it. The unit of molality is mole over kilogram. Short reminder, 1 kilogram equals 1000 grams. Comparison of the essence of concentrations. Molarity is defined as the number of moles of a solute per liter of a solution. Molality is defined as the number of moles of a solute per kilogram of a solvent. Molar concentration is used primarily in ebullioscopic or cryoscopic measurements, for example when measuring boiling or freezing points. The important fact is that the value of molar concentration does not depend on temperature change. Why? Why the value of molality does not depend on temperature change? Because the mass of the solute and the mass of the solvent, and therefore the mass of the solution, don't change with temperature changes. In diluted aqueous solution, molar concentration value coincides with the molar concentration value, and this happens because the density of water is assumed to be 1 gram per cubic centimeter. Guys, that's enough of the short theory. Now it's time for the problem. Calculate the molality of the solution obtained by mixing 11.7 grams of sodium chloride and 100 grams of water. Let's start by writing down what we know and what we need to calculate in this problem. We know already the mass of sodium chloride and mass of solvent, in our case water, and we are looking for molality of the solution. Molality is the number of moles of solute in 1 kilogram of solvent. In this problem, we are given the weight of sodium chloride, so we need to convert it to moles. In other words, we need to calculate how many moles of sodium chloride constitute 11.7 grams of this salt. The number of moles of any substance, for example, of compound X, equals weight of compound X divided by the molar mass of this compound. To convert the weight of the given compound into moles, we need to know the molar mass of this compound. So we start by calculating the molar mass of sodium chloride. I have already discussed how to calculate molar mass of compounds in the previous videos. In our case, we read the atomic masses of sodium and chlorine from the periodic table and write these values as molar masses of these elements. Then we calculate the molar mass of sodium chloride. The molar mass of sodium chloride equals 58.5 grams per mole. Now we know that each mole of sodium chloride weighs 58.5 grams. I will write down the molar mass of the sodium chloride under the problem data for two reasons. First reason, I have limited space to present the next stages of solving the problem. Second reason, by writing it this way, we know clearly what information has been provided already and what still needs to be calculated. Now, step 2. We convert weight of sodium chloride for moles. Let's do it two ways. First method based on formula. The number of moles of sodium chloride equals the weight of the salt divided by its molar mass. So 11.7 grams divided by 58.5 grams per mole equals 0.2 mole of sodium chloride. You can see that the grams are shorter here and we get the result in moles. Now second way, without formula. We know that 1 mole of sodium chloride weighs 58.5 grams. So x moles of sodium chloride weighs 11.7 grams. We calculate x by cross multiplying this proportion. So 58.5 grams times x equals 1 mole times 11.7 grams. To solve for x, we need to divide both sides by 58.5 grams. So it follows that x equals 1 mole times 11.7 grams over 58.5 grams. You can see that the grams cancel out here and we get the result in moles. So x equals 0.2 mole of sodium chloride. I will write down the number of moles of the sodium chloride under the problem data. Now we move on to final step, step 3. We calculate the molality of the solution. We know that in our beaker we have 0.2 mole of solute in 100 grams of water. To get the value of molality, we have to calculate how many moles of solute is in 1 kilogram, so in 1000 grams of solvent, in our case water. We calculate x by cross multiplying this proportion. So 100 grams times x equals 0.2 mole times 1000 grams. To solve for x, we need to divide both sides by 100 grams. So it follows that x equals 0.2 mole times 1000 grams over 100 grams. So x equals 2 moles of sodium chloride. Now we know that 2 moles of sodium chloride is in 1000 grams, so 1 kilogram of water. So this is the value of molality of the solution. Answer: molality of the solution equals 2 moles per kilogram. Summary of the solution to this problem. 1. Calculate the molar mass of the solute. 2. Convert the mass of the sample into moles. 3. Calculate the molar concentration, molality of the solution. Guys, that's all for today. Thank you very much for your attention. If you like this video, please leave a thumbs up and subscribe to my channel to follow the next subjects. I also invite you to leave comments. Thank you very much for your attention and see you in the next video.